Okay, class, now we look into the quiz answer for the retest one. Okay, so you are given protium, deuterium, and tritium. Okay, they are isotopes. So given to you, they are isotopes of hydrogens. So the diagram shows the atomic structure. So here actually is giving you the hint already. So how many protons, how many neutrons and electrons. Okay, so first question, okay, what is mean by isotopes? Okay, so they are what? Atoms of same elements, okay, that contains what? Okay, same proton but okay, different neutrons, okay, or different nucleon number. Okay, so here I need to remark here, okay, reject reject what? Reject neutron number, okay, and then also reject number of nucleon. Okay, next, state the name for all the subatomic inside, okay, inside the nucleus. So inside nucleus we have two only, right? So it's a proton and neutrons. Okay, but if the question asks you about all the subatomic in the atoms, then you have to include the electrons. Okay, so name the subatomic negatively charged. So it is the electrons. Okay, now do three hydrogen atoms in the diagram 1 have the same chemical properties? So again, here same chemical properties. Okay, yes. Okay, why? Explain your answer. Because the three atoms have same valence electrons. Okay, same valence electrons, that is one. There is one valence electrons. Okay, now diagrams shows the natural abundance for isotope of sulfur. So sulfur we have four isotopes here. So this is the protons. All proton number are the same, but nucleon number is different, right? And then you can see the percentage. Okay, now A already answered here. Okay, now state the number of neutrons for atoms 33. So 33 is this one. So what is the number of neutrons? So neutrons is the nucleon number minus the protons. So meaning that is 33 minus 16. So you will get is 17 protons. Okay. So next, draw the atomic structure for sulfur 34. So atomic structure, sodium 34 is this, right? So here you have 16 protons, meaning say 16 electrons. Okay, then proton is 16. Then how about neutrons? Neutrons here is 34 minus 16, so it will be 18 neutrons. Okay, So we can include all here. Okay, so 16 electrons. How we arrange in the electron arrangement? So first shell put in 2, then 8 maximum, then remaining 6. So it will be 2x6. Okay, so here sulfur. Okay, sulfur S. Okay, this is the nucleus. Then shell 1, 2, shell 2, 8. Okay, then 6, 2, 4, 6. Okay, so 2x6. Okay, so this one is the electron arrangement. If the atomic structure, so we have to include. Okay, how many protons here? Okay, you have 16 protons and 18 neutrons. Okay, so here, if your electron arrangement is correct, then you have to include the protons and the neutrons also. So you get 2 marks. Okay, next, calculate the relative atomic mass for sulfur. So this one already asked in the quiz 1, but sadly there are still some students cannot answer. So relative atomic mass, okay, equals to, okay, so total up, okay, so 32 is 94.93. So you total up, okay, 94.93 times how many percent? Yeah, 94.93% times 32. Okay, plus, okay, plus 0.76 times 33 plus 4.29 times 34 plus last one is 0.02 times 36. Is it? Okay, 36, 34. Okay, no 35, right? Okay, so total up, okay, divide by 100. So you will get 32.09. So your answer is 32.09 is the relative atomic mass. Okay. Okay, next question. Acetamide is an organic compound with the formula, okay, given to you. Diagram shows the temperature against time. Okay, so acetamide here you can see carbon, hydrogen, carbon, oxygen, nitrogen, hydrogen. So all these okay, what is the particles? So remember, if the question asks you particles, your answer should be atoms or molecule or ions. Okay, so let's see this inside here. This one not possible is atom because atoms only one. Molecule or ions here. Okay, so ions not possible because inside here no metal ions, no metal. Okay, so cannot be ion, so it should be the molecules. Okay, molecules. So what is the freezing point? Okay, so freezing point you can see when the temperature remain constant here, so you know this is the freezing point. So it's the value, you must give the value 80 degrees Celsius. Okay, now what is the physical state of matter at KL? K to L meaning that from here to here. K to L. So this one is the cooling, right? So cooling. So this one, it should be inside the solid state, right? Solid, should be the liquid state before it turns to, okay, should be liquid. Okay, so let's see here. So this one should be liquid, right? Okay, then start to freeze. So here it will be liquid and solid mixture. This one end to end will be solid only. Okay, then explain why temperature remain constant. This one I ask all of you to memorize in the classroom, but some of you is still I think less than 5 students can write this answer correctly. Okay, so for cooling, okay, heat release to surrounding, okay, is balanced by heat release during bond formation when liquid particles turns to solid. Okay, yeah, so you have to mention two things. Okay, heat release to surrounding. Okay, first part, balanced by what? Heat release during the bond formation. Okay, when the liquid particles turn to solid. So 2 marks. Okay, so everybody, you do the correction for those questions are wrong. Okay, yeah, so remember the format of this chapter for the questions for this chapter.